Online, please join. The very first topic on set theory. Set theory, or you will have the heading as sets in your chapter material. Sets, functions, and relations for CA Foundation and set theory for CMA Foundation. We'll go for the definition. Whenever we talk about sets, we should be very clear. It's not just a group, it's a group containing well-defined objects. The meaning for well-defined has a wider term, which means it will be unique. Okay, which means what? No repetitions allowed. Next, it will be distinct. Okay, no similar things. It will be condition based because it's not just a group, right? Because of some condition, because of common thing only we are having all these elements in the group. Two modes we can represent a set. One is by rule method and another one by tabular method. The alternate names for rule method is, you can call this a set builder method because this set is built because of this rule. Okay. Or because of this rule, you make the selection what type of object should be present in the set. So I can call this a selection method. Or it satisfies a particular property. So you can call this as property method. It defines the structure of the set. So you can call this as algebraic method. So four alternate names are there. So totally, how many names you have? 5 names. Rule method, set builder method, selection method, property method, algebra method. This is the name because it defines the. Whereas if we go for tabular method, you can call this as listing method, and this is found by Mr. Roster. So it's also called as Roster method. Okay. Tabular method is usually nothing but you list every element. What are the elements present in vowels of the English alphabet? A, E, I, O, U. You just list it. Okay. So it's actually listing the elements or listing the objects or whatever it is. That's why you call this as listing method or tabular method or found by roster. So roster method. So how many names we have? 3 names for this. So example. So I'm not going line by line. You can go through. We'll go for the different terms. First one is we call element or member or object if a committee is formed. Okay. Our Honorable Prime Minister is forming a committee. You cannot call the members of the committee as Madam, object element. Am I right? How do you call the members? As the members. Okay. Minister, MLAs, MPs. Okay. You call by the designation and you call by the names where you have a prefix over there. Okay. So you can use the term element or you can use the term member or you can use the term object. The notation what you use here is this symbol's name is called as epsilon, but how we read this one? It belongs to, this is equal to, this is not equal to, this is belongs to, so this is does not belongs to. Okay. We are talking about the member or element. So we have the example here. So if I talk about the vowel A, which is contained, sorry, which is belonging to the set A, so we call A belongs to A, right? Shall I go for the second one? Cardinal number. Always in mathematics or in statistics we call cardinal, will not call cardinal number, we'll call frequency over there. Okay. Here we use the term cardinal number. Cardinal means counting. It's about counting. How many is present? Okay. What is the size? Okay. Is the number of elements present in that particular set. The notation used is usually small n only. In rare cases, we may be using capital N. If I'm talking about two sets, set A and set B, I can call N1, N2 and so on. Okay. So N is usually meant for the notation for cardinal number. What's the nature? What this cardinal number can be? It can be a positive number. It can be a 0, but it's never negative. If it is 0, we call this as a null set. Okay. Now we'll go for types based on cardinal number. So if n is equal to 0, we call the set as no element present, so empty. Void, we usually use the term in mathematics void, which represents empty. Nothing is there means void or null set. The notation is quite important. We just open the bracket, close the bracket and leave it blank, and we can use this symbol. Could you please recall what the symbol is? Pi. Remember pi? This is small pi and this is capital pi. So we were talking all these stories. So this is 11th and I cannot bring back the stories again. Okay. Then if it is only one element in the set, we call it as singleton set. If there is a finite element number of sets, so which means a definite end is known, okay, defines an end, we call it as a finite set. Infinite set, where it goes on, we don't know where it stops, it called as a infinite set, defines no end. Okay, so example, we can take set of natural numbers, it goes on and on. After 1 lakh, if you ask me, I can tell it's 1 lakh and 1, I can tell, but still I don't know where it's going to stop. Okay, and AEIOU, that's the end. Okay, right? Then continuing, subset and other related sets will have a superset, and from that we vary the terms or the values of n. You remember, if n is equal to 3, we started here for this example. If n is equal to 3, we take n is equal to 0, we take n is equal to 1, we take n is equal to 2, and n is equal to 3. So that we get different subsets. Usually, for all the subsets, we'll take n is equal to 0. So default is the null set. Null set is a default subset for all subsets. How many subsets will be there usually? 2 per n. Okay, you remember how we got this 2 per n using permutations and combinations. We did this Pascal triangle, you remember? We did this Pascal triangle 1, 1. It can come or it cannot come. If it comes, one option. If it cannot come, one option. So 1 plus 1, 2. That's why you're getting 2 per n. Okay. Proper subset. Yes, proper subset, which is properly contained in a set. We cannot say that null set has a proper set because null set is empty. So how can you say that anything is contained in that set? No, no. So it's null set does not have proper sets. How many number of proper subsets present? 2 per n is the number of subsets. 1 will be equal to that itself. So 2 per n minus 1. Not equal and equivalent to superset. You can please make a note of it. You cannot say it's equal and equivalent to superset because if it is superset means we'll have all the three. For example, if I take this one, this is our example, right? What is a superset? Containing 1, 2 and 3. This is the subset which also contains 1, 2 and 3. See, if you talk about A and A7, A and A7 are equal, right? Equal means what? What do you mean by equal set? Containing same elements. A contains 1, 2, 3. A7 contains 1, 2, 3. So you cannot call this as proper subset. And what about equivalent set? I remember we used this symbol, some approximate like symbol. Okay. A contains n of A is 3 and n of A7 is also 3. It happens to be equivalent set. So we cannot say this as a proper subset. This is a subset alone. Okay. And superset, a set which contains the set. Okay. And what about the symbol? For subset, we use this symbol. This is contained and it can be equal to also. For proper subset, we say it's exactly contained, properly contained. Okay, we'll not have that equal to symbol. Then power set is set of all subsets. What's the cardinal number of power set? What is n of power set? 2 per n. See, number of all elements contained in the set. How many elements are contained? All the subsets are contained. How many subsets will usually will have? 2 per n. So cardinal number of power set is 2 per. Okay. Power set will never be a null set because we have a null set which is default a subset. Okay. Can you please go through it here? Yes, please. Complementary set and universal set. Universal set means it's a whole complete set. Okay. If I talk about English alphabets, we'll call this as universal set because only these 26 alphabets are present in this set, right? Sample space, you take a few elements from the universal set or it may be the whole set also. So set of elements, that's it. Complementary is the set which has elements not in that A. So if I'm talking about A, which is set of vowels, so let me go over here. A set of vowels, then A dash will be not in A is A dash, right? Set of consonants. Okay. So how you represent A dash or A bar or A complement. Okay. You call this as A complement. Universal sets notation is U. Okay. which means actually it's not U, but we say it's as U only. So if we take the universal set as U and the set is A, then A complement will be U minus A. Else you can say that universal set will be the whole of A, the whole of A dash. Am I right? Okay. In case if you're not talking about universal set, if you're talking about sample space yes, then sample space will be A union A dash. See, if I know about natural numbers, then it's okay. If I don't know what is the main set, then how can I talk about the A complement? So in that case, if no universal set is given, we'll talk about sample space. Okay. So S is equal to A union A dash. Okay. Yeah. So shall I write A dash is equal to S minus A? Usually this is not the method. Usually we have to write this only. Okay, universal set minus A only. But no other option will take S minus A. So you need not have a note on this. You need not have a note on this. Okay, continuing. Comparison or relation between the two sets. We can call it as equal sets or equivalent sets. Equal sets means you'll have same elements. This is the code word. Equivalent set means same cardinal number, same number of elements. Okay, which means equal number of elements. The notation usually we represent this is equal to and this is approximately like. So we call this as equivalent set. N of A will be equal to N of B. Please make a note of this one. Equal sets are equivalent sets, but equivalent sets are not equal sets. Need not be same. Okay. And other sets what we have? You can call ordered or product or Cartesian product. Okay. The representation we use here is cross symbol. Usually in arithmetic operation we call this as multiplication symbol. This is not an arithmetic operation. It's a set operation. We use it as cross. The term is cross used. Okay. So how you read it? A cross B. Which means it. Okay. I forgot this one, right? What is the normal representation of a set? Yeah. How you normally represent a set? We represent using a capital letter, then equal to, open a bracket, close the bracket, then this one usually we represent as x. This is such that this x is representing the element. This is what we call as a structure. So you remember in sequence and series we were discussing this one problem. You remember? Or we were discussing this problem. You remember? See, we call this as a structure. How it is being defined. And after this you will have the condition. What condition? Such that x squared minus 5x plus minus 4x plus 5 is equal to 0. Which means I cannot take all the x. The x which satisfies this equation can alone be taken. So this becomes a condition. Okay, so you'll have a condition part. You'll have this two dots. How you read this two dots? Such that. Okay. So now I come back here. Over here. So it will be represented here as A cross B such that A belongs to A and B belongs to B. See, the name is ordered, so it should go in order only. It is called as product, or we call this as Cartesian product because it's not a normal product. Normal product means it's the multiplication symbol, cross symbol. Here we are using the operation on sets. Okay, so we call this as a Cartesian product. Okay. And also you have to make a note that A cross B is not equal to B cross A. The only case where A cross B will be equal to B cross A will be when A and B are equal sets. But they are always equivalent, which means what? The cardinal number will be same. Okay. Then next is disjoint set. There exists no common elements, which means A intersection B will be equal to null set. No common elements. It will become a void set. Okay. So we have analyzed all these. First one. Yes, please join. Does null set has a proper subset? No. If we take a null set, this becomes the superset. Okay. And for this, if I take a subset, null set is the default subset, and this you can call as a subset only. No further elements to discuss, so we cannot talk about proper subsets. Okay. First one, I'll make a tick mark. Second, what pi is the default subset for all sets. Third, is there any subset equal to a subset? Yes. Okay. Which is not the proper one is the, see, I'll find what, in my example, we'll be taking A1, A2, remember A1, A2, A3, this A7. Remember this one? This A7 is nothing but 1, 2, 3. which is nothing but the superset itself. You remember? Okay, so definitely I'll have one set which will be equal to the superset itself. Then is power set can be a null set? Never, because we have this component second point where null set is a default set. So I can never say that a power set can be a null set. Okay. What is the power set of a null set? Yes, power set of a null set. How you represent power set? Power set of a null set is equal to, is a set containing all the subsets. What is the subset of a null set? Okay, it's 2 plus 0, right? Why it's 2 plus 0? Number of subsets in a null set. 2 plus 0, which will have only 1. So that one subset is a null set. Okay. Those who have not attended the regular lecture series on set theory, you have to focus on this area. Okay, you have to focus on this area. Then what is this one? Singleton set with null set as the only element. Okay, you can relate this one also. When is A cross B equal to B cross A? Only if A is equal to B. This is not X. Actually, this is cross product X. Okay. And this are both same. No, they're not same. This is a null set. Okay. This is a set containing null set as the element. So this is actually a null set. It's not a null set. It's a singleton set. Okay. Yes, please. You can go through till here. Make it. Shall I go for operations on sets? How many operations we have? Kindly join. One is union. Next is intersection. Union, intersection, difference. Fourth is symmetric difference. Usually we have a confusion whether we say complementary set as a operation or types of sets. Whatever it is, doesn't matter. When we go for union, you have to remember all these things. The notation use this U symbol. Please remember the U symbol, we use it for universal set also. That has a small difference, okay? So when we find A union B, we are talking about the operation. When we just write this U like, we are talking about the universal set U. Okay, this is an alphabet, this is an operation. Okay. So this is nothing but in wordings. We say this is either A or B. If it is in A, we take it. If it is in B, we take it. If there is both in A and B, we take it once. Because set as a definition having unique or distinct elements only. How we write it in representation? Set of all x such that x belongs to A or. See, the term itself is either or. So, A or belonging to B. Then intersection, it's a inverted U, which means both A and B. So, intersection B means belongs to A and belongs to B. Then difference, we use it as A minus B is not a subtraction, it's a difference. We call it as difference A minus B, which means only A but not B. So we need to have only A elements. The other way, B minus A means only B but not A, right? Symmetric difference, we use the symbol del, okay? So like small triangle like. So A del B, which is, we take A minus B, we take B minus A and union. Now let me come back for this one. Yes, A minus B means it should be in A. Okay, it should not be in B. B minus A means it should be in B. Okay, it should not be in A. Whereas for symmetric difference, it belongs to A minus B. So X belongs to A minus B or X belongs to B minus A. Because it is union, we have or. Union means either or. Because of union, we have or. Then fifth one is complementary set, which is A dash, which means it does not belongs to A. Okay. So we did with this Venn diagram. So Venn diagram, if you refer, we'll take for union the whole of A, the whole of B. If you have a keen note on the shading, you will find that this area is shaded, this whole A is shaded, this whole B is shaded. Okay. If there is a repetition, we will move it. That is, we'll remove it and we'll write only for once. If it is intersection means it has to be a overlapping set, then only can talk about intersection. If it is a disjoint set, what do you mean by disjoint set? No common element in both. So no common element means it will be a null set. Okay, we cannot talk about intersection. It happens to be a null set. See, you find the diagram here. We have taken in such a way that A and D is overlapping. Okay, so overlapping means the elements contained here is common to both A and B. Okay, difference A minus B. The notation, the wordings which we use is strictly only A. So only A. See, this is the area. So many get confused. Why not this area is covered? This is the area which belongs to B also, right? We are talking about only A. Okay, so this should not be covered. Whereas if we go for the other way, actually I don't have the diagram for B minus A, I'll draw it over here. This is A, this is B, this which I am drawing by stripes is the only B. Am I right? Symmetric difference, you take A minus B, you take B minus A, and the union. Union means whether it is an A minus B or whether it is an B minus A, you take both. So this area is shaded, this is not present. So shall I represent this as A union B minus A intersection B? Please check. Right? A union B is the whole A of A and B. A intersection B is a common one, so we remove it. Okay, right? And complementary set, you don't take A. And again, many cases, I'm talking about B, where there may be a set present C here, D here. Okay, it's not in my diagram, but it may be present. There may be E here, okay, F here. What we do? We take all those. See, we are talking about A complement, which means we are talking about the elements which are not in A, which means we are talking about the elements which are B, which are in C, which are. Yes. So probably in this figure, you might have noted on, particularly on A is properly contained in B and B is properly contained in A. Okay. And in this last case, we have this A, B and C, but our focus was on A union B, A intersection B alone, right? C will be there, but we'll not be focusing on C. You remember I was actually discussing in the regular series. Let me take a very rough one. This is A, this is B, this is C. If I go for A minus B, can you please help me out? What is A minus B? This one, right? So usually doubt raises whether I have to cover this component or not. When we say A minus B, we are talking about only A, okay, but not B. There is no role for C here at all. So we are saying that only A but not B. If we say only A, then your figure will be different. What would be a figure? Yes, please join. A, B, C, yeah. This one, right? Am I right? Because this is only A. Okay, fine. So A minus B is different, only A is different. A minus B is only A but not B, whereas only A means only A, no B, no C. Okay, so let me continue. Points to ponder. Yes, A minus B can be written as, what are the other operations you can use for representing A minus B? Yeah, please join. A minus A intersection B, you're removing the common part. This is with respect to two sets only, okay? A union B, from that you remove B, yes, you get A minus B. A intersection B dash can be taken. A del B minus B minus A can be taken, or from the complete triangle, sorry, not triangle, rectangle. Okay. Okay, you don't smile like this. Okay, I feel like I know triangles are three-sided figure, rectangles are four-sided figure. Okay, so universal set minus A minus B the whole dash. Okay, on three sets, Only A means only A. There is no B. There is no C. Actually, there is no equal to. I remember I corrected this one. And only A but not B means A and B are disjoint sets, which means A intersection B is equal to a null set. Then A union B will be equal to N of A union B will be equal to N of A plus N of B. This happens in this case. Am I right? Am I right? So whenever you find this type of a content where you find that A intersection B is equal to null set, automatically your mind has to say that N of A union B is equal to whole of A and whole of B. Is it okay? On three sets, you take the whole of A, you take the whole of B, you take the whole of C, minus A intersection B, minus B intersection C, minus A intersection C, plus, okay, A intersection B intersection C. When it happens that all the three are not overlapping. See, the fifth case we were discussing in the board was this one, okay, where A, B and C may be overlapping. There may be some cases, okay, there may be some cases where we may have like this. What's the difference? A and B overlaps, but C does not. Okay, there may be a case where A and C may be overlapping, but B may not be overlapping. There also may be a case where A, B, and C stand individually, independent, no overlapping. So in this case, A intersection, B intersection C, all the three is non-overlapping, so which is equal to null set, an empty set, an void set. Okay, in this case, N of A union B union C will be N of A plus N of B plus N of C. And other law we have De Morgan's law, A union B the whole dash. See, when we use this complementary operation, this union will be changed to intersection. Likewise, intersection will be changed to union. This is being found by De Morgan. That's why I call this by De Morgan's law. Commutative, A union B will be equal to B union A. For example, 2 plus 3 is 5 and 3 plus 2 is also 5. But 2 minus 3 is not equal to 3 minus 2. So, the same like we have A union B is following commutative law. A intersection B also follows commutative law. But A minus B will not be equal to B minus C. Okay. Associative is 3 sets and 1 operation where you will have both union, both intersection sign. The distribution is 3 sets and 2 operations, 1 union and 1 intersection. Okay. So, associative is, bracket is over here. So, let me have the description here. A union B, the A union B in brackets, union C. We just take these two, A union C. Okay, put it in brackets and take these two, B union C, put it in brackets. It's all same sign only. Associative will have only one operation. Okay, and put it the union outside the brackets. Whereas if you go for distributive, I'll have 3 sets A, B and C and 2 operations. So I'll go for the first one where union is inside the brackets and intersection is outside the brackets. So if you consider A intersection C, okay, you put it in brackets, B intersection C, you put it in brackets and union. Okay, the small hint is union is inside the brackets, it will come outside the brackets. This is the law what you call as distributive law. It's been distributed accordingly. And identity, or I think idempotent law, okay, it's there in CMA foundation material, where if you take the same set and take union, you'll get the same. You take the same set and take intersection, you get the same. If you take A minus A, it will be a null set. Okay, B minus B, it will be a null set. What is A dash minus A dash then? Null set. See, if the set is same, if you remove one from the other, because it's same, everything is removed. Null set. Okay. Okay. So, problems you can check in the regular series. Okay. Okay. In this word problem, you remember when the total number is not given, instead percentage is given, we take it as 100. If the total number is given and the percentage is given, we take it as percentage of number. For example, there is a total number of the survey is taken for 660 people. In this 10% like what? Bananas. Okay, so you can say 10% of this value. If this 660 people is not given, 10% like bananas, you take 10 people like bananas. Okay, so if no number is given, we take the total as 100. It's not an assumption, it's a basic logic behind. Okay. Also, you have to remember when we have this figure, when we talk about A, when we talk about B, this A union B need not be the complete sample space or universal set. You remember this one? Because there may be a D present, there may be a C present, E present, so this may not be exactly equal. Okay, where we were working this problem, you remember somewhere, I think this one. In a class of 50 students, how many failed in what subjects, etc. was given. Total is 50. And what was A union, B union, C, you remember? See, A union, B union, C is 42. Total is 50. So the 50 will be for the total whole rectangle. But when we talk about A union, B union, C, this alone is 42. Okay, so the remaining, which I am placing as dots, is nothing but 8 students. Okay, which is A union, B union, C, the whole dash. Done? Okay.